There's a few reasons why Arch is my go-to Linux distribution, and it's not just because I get to tell people that I use it, by the way. The main reason I choose Arch is because of freedom, or autonomy. It's an unopinionated distribution that allows me to set up my computer however I want to. Now, installing Arch can be kinda daunting for beginners, so in this video I'm going to show you how I do it with full disk encryption. The computer I'm going to use for this installation is a Beelink SE6 Max, which is a pretty power efficient machine, using around 10 watts when idle and a max of 80 when under load. Despite this efficiency, it's going to be plenty powerful enough for my day-to-day tasks. Out of the box, the machine comes with 32 gigs of memory, which is more than enough for any MacBook users. For storage, it comes with a 1TB SSD, which is not bad. However, for myself, I'm gonna need just a little bit more. Fortunately, it provides support for up to 2 NVMe drives, so I'm gonna add another 4TB. The drive I'm installing is a Crucial P3+, which I got from Amazon. You can find a link for all of this hardware in the description down below. To install it, I first need to open up the machine, which can be done by unscrewing the 4 screws at the bottom of the enclosure. Once unscrewed, I can then access the internals by using this tab on the bottom of the case, which is really helpful, as it prevents my fingertips from being embarrassed. Once inside, it's as simple as installing the M2 drive as you would any other, followed by reattaching the base and returning the screws to where they belong. With the upgrades complete, the next task was to obtain a copy of the Arch Linux ISO. Navigating to the download page of the Arch website, we're greeted with a number of ways to obtain this image. The recommended approach is to use a torrent. However, for those not comfortable with torrenting, then there are some direct download links available on the page. All you have to do is select the mirror you want to use and then download the image. Once the download is complete, it's generally a good idea to verify the integrity of the image. You'll notice on the direct download page that there are a couple of text files. These contain the expected hash sums of the image we just downloaded, which we can use to verify against. I'm going to grab both to show you how to use each one. You'll also notice there's a .sig file here as well. If you're extra paranoid like I am, then you'll also want to download this. Now we can verify our ISO image. Opening up a terminal and heading on over to the downloads directory, we can use either of the following 2 commands to verify the hash sum of the image. Next, to make sure you haven't downloaded an image from a malicious website, you can verify the signature of the ISO as well. You'll need GNU PG installed on your system in order to do this. First, use the following command to download and import the public key in order to verify the signature. Next, we can use the GPG verify command, which will check that the signature is valid. With that, we've completed our due diligence. The next thing to do is to flash this image onto a USB drive. I normally do this using the DD command inside of the terminal. And whilst this is pretty simple to do, it's also incredibly easy to accidentally make a mistake. And making a mistake with DD is a surefire way to destroy your system. So, being the responsible individual that I am, I decided to show how to flash this in a much safer way, using an app called Etcher by Balena. You can download this app from their website, and it supports all of the major operating systems. Once downloaded, open up the application and you should be greeted with the following window. Flashing with Etcher is really simple. Just drag and drop the ISO onto the application, then select the USB drive you wish to use. Once configured, all you need to do is then click the flash button. After a short amount of time, this should complete. Once it's done, eject the USB drive, insert it into your new computer, and power it on. At this point, you're going to want to intercept your boot menu in order to load from the USB drive. On a Beelink, this is done by pressing the F7 key whilst the machine is starting up. Upon selecting the USB drive as your boot disk, you should be greeted with another boot menu with a number of different options. Here I selected the first item in this menu, which brings me into the Arch Linux installation environment. To make things a little easier when installing Arch, I tend to SSH in from my other computer. In order to do that, however, I'm going to need to set up the box to have network access. The preferred option here is to just go ahead and plug in an Ethernet cable, and everything should work as expected. However, most people will typically need to use Wi-Fi in order to connect. Fortunately, this is actually rather easy to set up. We can use the iwctl command to do so. All we need to do is tell our WLAN 0 device to connect to our SSID, entering our Wi-Fi password when prompted. Once connected, the next thing you'll need to do is obtain the machine's IP address. You can do this using the ipadder command. Next, we want to make sure the SSH daemon is actually running. This should be enabled by default, but it never hurts to double check. All that remains is to set a password using the passwd command. This will allow us to log in when we try to SSH from our other machine. To do so, head back on over to your other computer and enter in the same command as I am. Make sure to replace the IP address with the one that we pulled out using the IP-adder command earlier. If everything's successful, you should be greeted with the Arch Linux installation welcome message. The first thing we need to do when setting up a new system is to ensure that our disks are set up correctly. In my case, I want to install Arch on an encrypted volume. For doing that, however, it's a good practice to overwrite your disk with random data, in order to hide where your data boundary lies. To do this, we first need to locate the path towards our drives. We can do this using the lsblk command, which will list all of our block devices. The drives I'm looking for are both of the NVMe ones. The easiest way to write random data is to use the dd command with the /dev/u random device. Now, this command takes a long time. In my case, it took around 8 hours in total in order to overwrite both drives. If that is, understandably, too much time for you, then this step is totally optional. However, it does secure your data just a little bit more than not doing so. In either case, the next step after this is to set up our disk partitions. I pretty much have a standard table that I use when it comes to partitioning my disks, which is separating the boot disk into 3 distinct partitions. The first of these is the EFI part, which will contain our Linux image. The second is used to contain our bootloader, which in our case will be grub, and the last partition is an encrypted LVM containing multiple volumes. As this system has 2 distinct drives, the second drive will be used as an encrypted partition for storing the /home directory. If you're only using a single drive, then don't worry about the home partition. I have a link to a guide in the description down below which covers both setups. To set up my partitions, I'm going to use gdisk on my boot drive, which for me is NVMe 0 and 1. To see the current layout, I can use the p command inside of the menu, which shows I have no partition table, as expected. To create a new partition, you use the n command, and use the defaults for both the partition number and the start sector. As I want this partition to be 512 megabytes, I'll set the last sector to be a size of +512M. We then need to give this partition a label type. We can find the code we want using the L command and typing in our search string. As this is the EFI partition, I can search for EFI, which produces the EF00 code. Afterwards, I can check this partition by printing out the table again. Next is to move on to the boot partition, which follows a pretty similar setup process. I'm setting the size of this partition to be 4 GB, however. Again, we'll search for the code we want using the L command, which will give us the EF02 code. Once again, I'll check that everything looks good by printing out the partition table. Then it's time to move on to the third and final partition. As I want this partition to take up all of the remaining space, I just need to accept the default for the last sector. Because this partition is going to be encrypted with Linux LUKS, the code for this partition is 8309. With our partitions defined, we can then use the W key to write this table to the disk. Next is to set a partition on my home directory drive. As this drive is only going to contain a single partition, I can accept the defaults that gdisk provides in order to use the entire disk. This partition will also be encrypted, so for the hex code you can either use the same LUKS code we used before, or, as I'm doing in my case, using the Linux/home code, which is 8302. With our table now defined and written, the next step is to set up encryption on both my LVM and home partitions. To do this, we're going to use LUKS, or Linux Unified Key Setup, which comes as part of the Linux kernel. To begin, it's a good idea to make sure the encryption modules are loaded, which we can achieve using modprobe on dencrypt and dmmod. The first partition we're going to encrypt is the third partition of our boot drive. We can do this using the following command, specifying the partition we want to encrypt at the end. When it comes to the LUKS format command, there's a whole bunch of configuration you can choose from. However, I find this is the best configuration for me because it's both simple and secure. After submitting this command, you'll be prompted to enter in a password. It's always a good idea to keep a copy of this password somewhere safe, in case you forget it. Personally, I use a self-hosted password manager, which also has an off-site encrypted backup. Once the first partition is encrypted, I can use the same command again on my home partition, going through the exact same steps. You can use either the same password here or use a different one, whichever your preference. With our encryption complete, the next step is to add logical volumes into our LVM partition. To do so, first use the following command to decrypt and mount our encrypted partition where we're going to be defining our volumes. Let's mount this under the mapped device of lux_LVM. Next, we can then create a physical volume using the pvcreate command under our mapped device, followed by then creating a volume group named Arch. Once that's done, we can then create a logical volume for our swap device. As I plan on upgrading my RAM to 64 GB, I'm setting the size of the swap volume to be 96 gigs. This means it's able to store all of the contents of memory on disk, with a little bit of a buffer. After the swap volume, it's then time to create the root volume. As I'm using another disk to store my home partition, I'm going to set this volume to use the remaining free disk space by using the following command. Once that's done, we can check these new volumes by using the lsblock command. The last thing for me to do is to decrypt and mount my home partition, which I'm going to mount at arch-home. With our volumes defined, we can go ahead and set up our file system. The first partition we want to format is where our EFI will be stored. For this, it needs to be FAT32, which we can format using the following command. For our boot partition, we can use ext4. For my root and home file systems, I prefer to use btrfs, which provides a number of additional features, such as full system snapshots and rollbacks. We can format our two partitions to use btrfs by using the makefs.btrfs command. With our home and root partitions done, the last thing we need to format is our swap volume, which we can do using the makeswap command. With that, we finally have our file system set up how we want to. Now we just need to mount it in order to install Arch. First, let's mount our swap space by using the following two commands to first enable the swap and to mark it as available. Next, mount the root volume to the /mnt directory. We can then use the makedir command to create both our home and boot directories. With these created, we can then mount our boot partition to the boot directory and our home volume to the home directory. The last thing to do is make a new EFI directory inside of the boot folder and then mount our EFI partition to it. That's a lot of mounts. I recommend double checking yourself using the lsblock command. Here's what mine looks like. With that, we're now ready to install Arch. Finally. Setting up disks always takes such a long time. To install Arch on our system, we can use the packstrap command, passing in the base, Linux, and Linux firmware packages. If you want to do a hardened installation, which is a little more secure, then you can use the linux-hardened package instead. However, do be aware that some apps may not work on your system. I recommend reading the documentation to find out more. Once pressing enter, the command will download and install all of the packages onto our file system. This will take a couple of minutes depending on your internet speed. Once it's done, we then want to make sure we save our file system table to our new system. This can be done using the genfstab command, writing it to the mount/etc/fstab file. Now we can load up a shell inside of our system using the arch change root command on the /mount directory. This now acts as if we're root inside of our actual operating system. The first package I like to install is the base develop package, or base devel, which provides a number of features for software development. We also could have specified this package inside of the packstrap command if we wanted to, but as not everybody is a software developer, then I chose to omit it for this video. With our base packages installed, we now need to do a little more configuration in order for our operating system to be able to boot. To do that, we first need to install a text editor. In my case, I'm using NeoVim. However, if you're not comfortable using Vim key bindings, then I recommend using Nano instead. With your choice of editor installed, we then need to open up the /etc/makeinitcpo file in order to configure Linux to decrypt our volumes when it starts up. To add this in, scroll down to your hooks line inside of this file. Here, make sure to add both the encrypt and LVM2 hooks in between block and file systems. Then go ahead and save and exit this file. Once that's done, we then need to install the LVM2 package on our system for the hook to be available. This will also regenerate our Linux image. Next, we need to install our bootloader, which in this case is going to be grub. In order to set up our bootloader, we're going to need to install both the grub and EFI boot manager packages onto our system. Next, we need to install grub onto our boot partition. We can do this using the grub install command as follows. Then, once installed, open up the /etc/default/grub file in your text editor. Here is where we're going to set some kernel parameters to our boot configuration. The first is the partition that contains our root file system, which in my case is pointing to the arch root volume. The second is to mount our encrypted device to the Lux LVM volume. Here I've specified the path to the partition. However, this isn't exactly a best practice. Sometimes following a CMOS reset, the device ordering can change, which can break the operating system from loading. A better practice is to use the device UUID instead. You can obtain this using the following command in the terminal. Then copy it to your clipboard, head back into the grub configuration, and make the following changes to use it with the crypt device. With our kernel parameters configured, the next thing we want to do is make sure we only have to enter in our encryption password once. To do this, we can make use of a key file for each of our encrypted partitions. I like to store my key files in a directory called secure, which we can create using the following command. If you can think of a better place to store these, then let me know in the comments down below. The next step is to create a key file, each for our root directory and our home directory. We can do this using our old friend, the dd command, sourcing from dev/random and outputting to our respective files. Here is the command that I'm using to create them. Next, we want to lock down the permissions on these files so that only the root user can access them. We can do this by setting the permission flags to 0 using the changed command. It's also a good idea to change the permissions on the initramfs as well, as this will contain the key file. With our key files created, we then need to add them to each of our partitions respectively. We can do this using the lux add key command, entering in our existing passphrase when prompted. Here I'm doing this for both of my partitions. With our key files created, the next thing we want to do is make sure that the kernel can access them. Opening up our makeinitcpo.conf file again in our text editor, head on down to the files line. Here add an entry for the root key file. This will ensure that the bootloader has access to this file when the system starts up. This sets up the root volume. Next is the home partition. For this, we're going to use the crypt table. In order to modify this, first obtain the UUID of the home partition. Then open up the /etc/crypt tab in your text editor. Inside, add the following line. The first column defines the mount path, which in our case is arch-home. The second column defines the device, which we're referencing by its UUID. And the last column points to our home's key file. Once that's added, the first thing to do is regenerate our Linux image using the following command. Then we need to initialize our grub configuration. We can do this using the grub makeconfig command and outputting it to both the boot/grub/grub.config directory and another instance into our EFI directory. This will enable grub for both BIOS and UEFI systems. With that, our boot configuration should be complete. All that remains is to do some final setup on our system. The first thing we'll want to do is make sure to set up our time zone and locale correctly. You can do this by creating a symbolic link to the region and city that's within your time zone. For me, I'm choosing the America region with the Chicago time zone. If you're not sure which one to use, then you can always check the contents of these directories to find out which one best suits you. As well as setting your time zone, you may also want to enable NTP, which stands for Network Time Protocol. To do this, first open up the timesyncd config file, and then make sure to set the primary NTP servers as follows. It's also a good idea to add some fallback servers here as well. You can use the same configuration that I am. Lastly, we just need to enable the timesyncd service in systemd. Next, we need to define our locale. First, open up the etc/locale.gen file inside of your text editor. Then scroll down to the UTF-8 language that you want to enable. For me, I'm using the US English language, despite my accent being British. With our locale configured, we can then use the locale-gen command to generate any needed language-specific files. Next, you'll need to add a language entry into your locale.conf. Open this file up in your text editor and then add in the following line. If your primary language isn't US English, then I recommend checking out the Arch Linux documentation to see which value to use. Next, we want to give our computer a host name. This can be whatever you like, but do make sure to give it something that you'll easily remember, as it'll be the main identifier on your local network. It'll also show up in your terminal prompts as well. Next, we want to make sure we secure the root user, and then add a new user account that we can log into instead. Let's first set a password for the root user using the passwd command. Next, I'm going to go ahead and install zshell, which is what I want the main login shell for my user to be. You can change this to be any shell you prefer. Now we're ready to create our own user account. We can do this using the user add command. Here we're telling it to create a user directory with the -m flag, setting the group the user belongs to as wheel using the G flag, and setting the login shell of the user using the -s flag, which in my case is zshell. And lastly, we're setting the user's name. With our user created, let's go ahead and set their password using the passwd command. As our root user has been locked down, we want to give the ability for our new user to escalate their own permissions. To do this, we need to edit the sudoers file. First, make sure to set the editor environment variable on your system to whichever editor you're using. Then you can run the sudo command to open up the sudoers file. In my case, I want to make it so that any member of the wheel group is able to assume root permissions. I can do this by uncommenting the following line. Next, we're going to want to make sure our machine is able to connect to our network. The simplest way to achieve that is to install the Network Manager package, as follows. It's also a good idea to enable this on startup using the system control enable command. Lastly, it's time to install a desktop environment. For this video, I'm going to show you how to install Gnome, as it's one of the more simple desktop environments to get started with. To do so, just run the following command and make sure to enter in the selections as you go through. For the first option, I'm just using the default of all, and then I'm selecting the second option for the next two. This will download a lot of packages, which is one of the criticisms people have of Gnome. Personally, however, whilst it does include a lot of bloat, I think it's one of the best desktop environments for first-time Linux users, especially if you're coming from macOS. Once that's finished, we then want to enable the Gnome Display Manager, which provides a UI for us to log in and load our desktop environment. With that, everything should be working. However, there may be another step you might want to take. This is installing Microcode on your system in order to speed certain processes up. As I'm using an AMD-based system, then I'm going to install the AMD Microcode package, using the following command. If you're on Team Blue, then make sure to install the Intel Microcode package instead. Once installed, we then need to regenerate our grub configuration file. We can do so using the following two commands. With that, everything now should be complete. Let's shut down the installer and reboot into our system safely. To do that, first exit the change root shell by typing the exit command, and then unmount all of our drives using the umount command with the -r flag on the /mount directory. Once that's done, you can then use the following command to reboot the machine. Whilst it's rebooting, you can pull out the USB stick, and you should load up into the grub boot manager. Select the Arch Linux installation, and you should be then prompted for your password to unencrypt your disk. After that, you'll then be greeted by the Gnome Display Manager. Log in with your user account, and the Gnome desktop environment should then open up for you. With that, we've successfully managed to set up an Arch Linux installation from scratch, with disk encryption. You can also find a link in the description down below to a guide with all of the commands used in this video. From here, it's the perfect launchpad to configure our system further. Now, I have a few more videos coming, but if there's anything you'd like to see, then please let me know in the comments down below. Otherwise, a big thank you for watching, and I'll see you on the next one.